In this short video, I'm reviewing what we covered on operational amplifiers, op-amps. Okay, if you remember, we used an op-amp circuit on your integrated circuit board to drive your speakers. And so I wanted you to know a little bit about how that works. All right, so we had talked about certain idealized assumptions for analyzing op-amps. One of them was we have an infinite input impedance on the input side of an op-amp. And another is that the op-amp has really high gain, across the between input and output in open loop. That probably doesn't mean anything to you, but ultimately what that means is there's a virtual short condition that happens between the inputs of the op-amp. Okay, so those are a couple of things I wanted you to know. And what that means, the infinite input impedance assumption means this current coming in is essentially zero. Okay, and the virtual short condition means that if you have a voltage here, like in this case this is tied to ground, so that'd be 0 volts, then that means across the terminals, because this gain is really high, this would have to be 0 volts here as well in order for this not to zoom off to infinity. Okay, so there we go. That's the assumptions that I want you to know about an op-amp. All right, so let's also recognize this pattern. Okay, what I have here is the output of an op-amp circuit, and the output is tied back to the input side. That's a feedback path, and here's the input side, VI. All right, we did the analysis in class, but you don't have to know all the details. What I want you to do is remember this formula, that for an operational amplifier, in the ideal case, the output is minus RF over R times the input. Okay, where this is the feedback resistor RF, and this is the input side resistor R. Okay, so the kind of question you could answer is that for this particular resistor combination, what if I put in a waveform that looked like this, a little triangle up and then triangle back down. All right, so that's the waveform. Let me trace it in red so you can see it. There's the input waveform. Let's say this voltage here is 1 volt. That's the peak. And so this is the input. All right. What you'd be able to tell and be able to reproduce on an exam is what the output should look like. So here's V out. We still have time here. Okay. In this particular case, RF is 10K, and R on the input side is 2K. So that ratio, RF over R, is 10K divided by 2K with a minus sign. So this is minus 5. The gain is 5. All right, and the minus sign just means the waveform is inverted. So if I was going to plot the output, it would have the same shape, only instead of going to 1, it goes to minus 5. It gets multiplied by 5 and flipped over. So it would look like that. Okay, this is called an inverting amplifier, and that's what you did in lab.